Okay, we talked about the fourth and final point of concurrency, and that's called a orthocenter. Orthocenter, the altitude to intersect. All right, there is no fancy fact you have to remember. Congratulations, no fancy fact. But I need you to know where it's located, though. All right, where to find the orthocenter on a triangle. We talked at the end of class. Triangle. It will be located somewhere inside. And here is why. If you have an acute triangle, all three of the altitudes are somewhere inside. The altitudes will never be, or somewhere inside, excuse me. The altitudes will never be outside anywhere. Right triangle. Everyone ready for a right triangle? Because this is a special one. Where's 10? 10? Explain to me and your classmates. And it's got to start where? Okay, starts at a vertex, makes a right angle on the opposite side. Look at a right triangle. Starts at a vertex, makes a right angle to the opposite side. Isn't that this line right here? What do I call this on the right triangle? That's one of the... Okay, so one of the legs is also an altitude, guys. One of the legs is also an altitude. Can you find another altitude that's already drawn? Where is it? Another leg. Yeah. The other leg of a right triangle is the other altitude. You see where those two intersect? Do you see where those two intersect? What's that point? Where the altitudes intersect. What's that point called? Orthocenter, yeah. So for a right triangle, it's not inside. It's not outside, but it's on the triangle. Specifically, I would put in parentheses where on the triangle. How can you describe that location? How about where the two legs meet? All right, where the two legs meet. All right, so for a right triangle, it's going to be where those two legs meet. And then, anybody know the last type of triangle I have here? Obtuse, yep. John, one more time for you and your classmates. What's an altitude again? But it's got to form a what? Okay, watch. Don't draw this in. Any shot that any of those two are right angles? Any shot? No. Okay, let me try this again. What about right there? Any shot, those two are right angles. I can't make a line inside that's going to make a right angle. Does everyone agree on that obtuse triangle? The only way I can make a right angle from this vertex is if I just draw it somewhere on the outside. Everyone agrees? That's the only way I can make a right angle because it's never going to happen inside. So if this altitude is on the outside, where's the orthocenter have to be? On the outside as well. So again, no fancy fact, but I need you to know where the orthocenter is located based on the type of angle that I have. All right? Questions from you guys? All right, you ready to review all of this now? All right, without looking back. Little mini quiz right now. Mini group quiz. Here we go. This is a summary of everything. Without looking back, can we do this? Let's start with a perpendicular bisector. Draw a I'm not worried about the description at all. Draw a triangle, please. A perpendicular bisector must go through the what? I'm glad some of you are saying vertex. No, it does not. It is the only one of these four that does not have to go through a vertex, but it has to go through what of a side? Midpoint, and it's got to be perpendicular. So do your best right now. Try not to have it go through a vertex, but make it look like it's going through a midpoint and perpendicular. Put your perpendicular sign bisecting, so put your hash marks. It does not have to come from a vertex. Does not. If I drew in all three, name that point of intersection. If I drew in all three perpendicular bisectors, 28, name that point of intersection. It is called the circumcenter. Nice job. What is the special fact about a circumcenter we need to remember? Special fact. 2 days ago, we went over at 14. Special fact. Equidistant from the... Okay, angles, vertices of the triangle, right? Equidistant from the vertices. All right, equidistant from the vertices. Angle bisector. Draw a triangle. Go ahead, another triangle, please. Draw a line that bisects one of the angles. Just sketch it. We're going to do all these constructions here right now. So go ahead. What should you be putting on your diagram that shows me it bisects? Arc marks, yep. If you drew all of them in, where would they intersect? That point called the, and this is where we got to be, 4. Where's that point where they all intersect? In center. Nice job. IN center. What's so special about the in center, guys? What's so special about it? Here you go. 22. What's so special about it? Go back and look it. You'll remember it if you go look it up now. In center. There we go. Equidistant from the sides. We're all good so far. All right. We talked about yesterday. Go ahead, draw yourself a triangle. For a median, what does a median look like? $19. What's your median look like? Where's it got to start? Well, not necessarily. Well, it's got to go to a midpoint. But don't. Hey, guys, don't assume that this is the only median in that. It could start at any vertex. I could start it from here and go here as long as it goes to the midpoint. All right, as long as it goes to the midpoint. If you drew all of them in, where do they intersect? 18, where do they intersect? Talked about it yesterday. It's a big one for us. Centroid. And what's so special about the centroid from yesterday? Here you go. 13. What's so special? Breaks median into 2 to 1. Yep. And finally, altitude. I think we've exhausted this one. Again, going back to Billy's point, does it have to start at the top? No, it's from any vertex, guys. It can go to the opposite side, any vertex. And we just went over what are all the altitudes intersect at. Here you go, 21, where do they all intersect at? All 3 altitudes intersect at the, that is the medians we just went over. Look back, we just reviewed it there, Jack. All 3 intersect at a point called previous page from this one. Should you just flip back a page for me? It's right at the top. I don't want to know. No. I want to know where all three altitudes. Somebody help this poor kid out. What's it called? Orthocenter. There is no fact, but you should know what? What type of, you should know where it's located based on the triangle. All right, so no special fact, but know where it's located. Whew. Know and love this chart. All right, know it and love it. Here's what we're going to do today. Can you construct all these now with your compass and straight edge? Construct these, and the answer is you're darn right. Let's get to it. We've done most of this already. You're just going to put two of them on one now. So I'm going to go quick here because some of this is review here at the beginning. All right, let's start building up here. Constructing a midpoint. Everyone just take your straight edge and draw a line segment for me. Let's go. Take your straight edge, draw a line segment. Put endpoints on that line segment. A, B, C, D. Okay, let's grab your compass. How do I find the midpoint? I do the fish construction. Take your compass, put it on one of the endpoints, and open it up. More than half the distance of your line segment. Do a decent size arc. Keep your same compass opening. Go to the other side. Do the same thing. Line up your straight edge. And I asked you to locate the midpoint, so please have endpoint M. Make sure you put a little hash marks at each side so I know that's the midpoint. Okay, all good there. I'm going to go quick here, but we've done these already. Ready for everyone? All right, construct the midpoint. Here you go. Where do you think I might want to use this construction for? What have we talked about? Midpoints already yesterday. Medians, yeah. I may need this construction when I'm asked to do a median. Let's keep building off of that. Medians lead to what? All three medians intersect at the centroid. Might need this construction for the centroid. All right, this is why I'm showing you these basic ones now. A perpendicular line from a point not on the line. All right, so everyone draw a line for me. Put some arrows on that beast. And draw a point somewhere off the line. Somewhere off the line. Doesn't matter where, somewhere off the line. All right, I need a line perpendicular to the one you drew, but it's got to go through the point you have. So a perpendicular line going through it. All right, take your compass. Put your compass point on that point. And anybody remember what my job is now? Twice, yeah, I got to hit this line twice. So I need to make an arc mark that intersects twice. And if it doesn't intersect twice, go back and make your line longer in one direction. Make it intersect twice. Usually from here, I open up mine just a little bit. Open it up just a little bit more. Remember where to go from here. How many points of intersection do you have on your line? 2. Go to each point now. Go to each and then draw 2 more arcs. Line it up with your straight edge. And draw in that perpendicular line. Any issues so far? Where might I want to use this construction where they give me perpendicular lines? Altitudes. Keep building. Altitudes lead to what? Orthocenter. Yeah, so I may need this construction for altitudes or orthocenter. Perpendicular bisector. Here you go. Make a line segment with your straight edge, please. Not like mine there. Perpendicular. We've already done it. Which one's the perpendicular bisector? The one that finds the midpoint, right? Bisectors go through midpoints. It's the same construction. That construction finds a ton of stuff, huh? Open it up, more than half the length. Oh, you don't have that one? Oh, bisect. Oh, all right. Never mind. Sorry. Somebody would have chimed in earlier with that. Sorry. Bisecting angle. How about that one now? Thanks, everybody. So go ahead and draw yourself an angle. Freehand one. That saves a little time, huh? Okay, how to bisect this one. Put the compass point right there on the vertex. Make an arc through both rays. How many points of intersection do you have? 2. Go to each point right now. Little fireworks action. Make sure we put some arc marks to show me they're congruent. What might this, well, no. There you go. This may help us construct what? Angle bisectors. Angle bisectors. Angle bisectors. Where do they all meet in a triangle? In center, yep. This may help us lead to the in center. All right, let's get into some new stuff now. The median A to X. So it's going to go from A to a point somewhere on here, X. Medians. This is why it's crucial that we understand the definitions here. Medians are drawn from a vertex to what? Vertex to a midpoint. Yes. You don't have this one either? We're on fire here. Okay, construct the centroid. I better get to that one then. Construct. How about this one right here? Yeah. All right, here we go. I got 2 compasses on here. We're a hot mess right now. And now the pen's not even working. Nice. All right, I'm just going to talk as we get this fixed. Centroid. Intersection of the what? Medians. You only need to do how many medians? 2. Where do medians go to? Midpoints. Sure, why not? Yep, just keep going. Calm down, boss. This isn't my first rodeo. May look like it, but. All right, back to business. Construct the centroid. So here's where your thought process. Centroid is the intersection of the what? Medians. And what do you know about a median? Goes to midpoints. Yeah, so do we know a construction that could find the midpoints of two of these sides? This is why I just reviewed it. Absolutely. All right, here we go. Which one do we want to do first as a class? How about BC? All right, please. You're going to have a lot of arc marks going on now because you're going to have to do this for two sides. Okay, I can't even. Just kidding. All right, I'm going to walk around and help you guys out. So go ahead, find the midpoint. You don't need to draw that full line in. You're only going to find the midpoint. That's fine. If you drew that line in, that's fine. But that's not my median, remember. Not going to play. Okay, you guys are finding the median, right? But where do medians always start? At a vertex. So once you guys find the midpoint of BC, connect it to A with your straight edge. Connect it to A. What you guys are just drawing in is a perpendicular bisector, which is fine, but I need a median. So connect that midpoint to A. And that's your first median. Go to another side. Find the midpoint of a second side, please. Now connect. Once you find the second midpoint, connect it to the opposite vertice. Well, I'm not on that one yet. No, just on the centroid and median one. Good. You remember, you only have to do it for two sides if you're good. On point. Nice. Look around in your group. Make sure you guys got the centroid about the same spot. Looking good. Yep, we're all in about the same spot. Good. Perfect. Nice job, everybody. Okay, looks like we can go on now. Next one is, what am I asking you to find in the next one? The Circumcenter. All right, let's talk circumcenter. That's the intersection of our perpendicular sectors. Do we know how to make a perpendicular bisector? Now, hey, you just did it for the medians. But now all you have to do is draw the line through. You don't have to connect it with the vertice anymore. All right, so do your fish on two sides, draw your lines through, and that line you're drawing through is your perpendicular bisector. Once you connect it to a vertice, that makes it into a median. All right, but we only need the bisectors here. We only need the perpendicular bisectors of two sides. So draw it in. Where those two lines meet, that'll be your circumcenter. And I'll show you guys a nice little check we can do with it. So draw your perpendicular bisector, just draw the lines through, that's all you need to do. And you'll find your circumcenter, and I'll show you a great way to check it. Perpendicular bisectors do not have to come from a vertice. We'll check it in a second to see if it's the right one. Now do it for a second side, because I need two that intersect each other. Right? It's okay if it goes outside. It may intersect outside the triangle. That's fine. Keep extending them. Keep extending them, because I need these two perpendicular bisectors to intersect. Okay, hold on, hold on. You need another, because it intersects here, but where else does it intersect? Like, you need to keep going with your arc marks, because I need 2 points of intersection, one on top, one on the bottom. So that's where you can line it up, because I don't know where you're lining this one up with. Like, which way do I line? I got to line it up with something that intersects up there. Okay. Keep extending them, Jack. Keep extending them. I need to make them intersect, right? So keep going. It's okay if it's going to be on the outside. Good, good. Okay, you guys think you know where it is? Here's a great way to check. The circumcenter should be the center of a circle you can draw around the outside of the triangle. So here's how you check if you had the right one. Everyone, take your compass point and place it right on where you think your circumcenter is. Put your pencil point on one of the vertices of the triangle and start making a circle. Please do not draw on the desk, because I think it may run off your paper, but it should hit every vertice of your triangle right now, or come pretty darn close to. Yeah, look at that circle. Yeah, on the outside. Yep. That's how you know you have the correct circumcenter. It should touch every vertice of the triangle pretty close. Not bad? What's that? We'll take it. It's not bad. We'll take it. Okay, next one. You got the circumcenter. Let's go to orthocenter. Remind me, the orthocenter is the intersection of the what? Orthocenter. Altitudes. What do altitudes do? Start at a vertice and does what to the opposite side? Perpendicular. Everyone, let's go. Put your compass on point A. Put your compass on point A. Remember how to do a perpendicular line from a point. Make it an arc that intersects BC in two spots. And if you can't, extend BC, please. If you can't make it, extend BC if you can't do it. From point A, make an arc that intersects BC in two spots. Open up your compass a little wider. Go to each point of intersection at the bottom and make 2 more arcs below it. And then draw in your altitude. Try it from another side now. So go from B or go from C now. So put your compass point on B or C and try to do it again. Once you get one altitude in, now put your compass point on B or C. And do another perpendicular line to the opposite side. You pick now. Put your compass point on B or C. You may need to extend that opposite side again. If you can't make it intersect the opposite side twice, extend it. Whatever we don't get done, you are finishing for the homework tonight, remember? Okay, take your compass. If you need to borrow one, take one home. Finish up that construction and the one below, and finish the rest of the packet pages, please.